to the class, and let's come back to the lecture. And before the break, we talk about how to calculate the moments if both R and F are in 3D and have X, Y, and Z components. Remember the first row we have IJK, the second row we have R, and the third row we have F. And you can check this by you go this way and then go this way. Now, if in some cases we have let's say we know MO. MO is known, and we want to determine MB. And here we can actually let me draw a simple. Let me draw a figure on the space. And we have O here, and O here, and then we have A here, and we have B here. Now we have A here, O here, and B here, and we have here. We have R A with respect to O, and here is R B with respect to O, and we have and here. Now, let's say we know MO, which is R cross M, right? Take your time to draw this, and I will. Yes, take your time. Let's say we know MO here, and moment arm is OA, which is R in respect to O, and we know that. Now we want to determine the MB, which is so we need to draw the moment arm by this in theory, right? In theory, we have RA with respect to B. This is the moment. If we want to calculate the MB here, so if we take on B, if we take the moments with respect to B, of course we have, and the moment arm is this leg, and then cross M. But sometimes it is not easy to calculate this RA with respect to B. So we can break this vector down into two parts, which is A with respect to O minus B with respect to O, which is because B with respect to O is this one, and so the minus R is sorry, minus R is in the opposite direction. Okay, so so this can be, this is also okay. Now we go, if you are okay, then you can go to the next page. If you are finished writing this, and go to the next page. Now, sample 3.1. A vertical force is applied to the end of a lever, and the lever is which is attached to a shaft at O. Shaft is this one, attached to the vertical force is applied to the end of the lever, which is attached to a shaft at O. So determine the moment of the 500 Newton force above O, and the horizontal force applied at A, which creates the same moment above O, and smaller force applied at A creates the same moment above O. Whether these are equivalent of original force. We have 4 parts to answer. Okay, we have 4 parts to answer. So this force is 500 Newton going down vertical, and we determine the force, the moment of this force about O. So we have the moment arm of 0.6. This part is the moment arm. Okay, this part is the moment arm because the force is applied at A. So we have moment arm here. And the angle here is 150 degrees. Of course, you can say this one is 30 degrees, then it is also okay, because this is 30 degrees. It is also okay. Now, so the moment of this 500 Newton force above O, it is easy. So the only thing you need to take care is for R and F, which one goes first? F times R or R times F? R times F, okay? R times F times sine theta. Okay? R comes first. And because it is a 2D problem, we can draw. This is a counterclock. This is clockwise. Sorry, this is clockwise. Okay. And for the next part, so then the horizontal. So it asks for if the force is horizontal, which is F prime, and this is also 0.6 meter, and we have this. You don't need to draw this, but I have. This is R, this is O, and this is A, and this one is so we want to, and we know that the moment will be the same, but we don't know the force. We know that the moment will be the same because the question asks for what if the moment be the same. So we have R F prime times sine 60 degrees because this one is 60 degrees. So R F prime times sine 60 degrees. So F prime is 288.5 Newton to the right. It's okay. And in past, so take a time to write down those or draw things down. And remember that again that we have R first and F second. And for part, so the answer part is this one. So if you're okay, then we go to part C. What does part C ask for? The smallest force applied at A, which creates the same moments about O. So if the force is applied at A, the moment R would be 0.6 meter, right? Because OA is 0.6 meter, so the moment R would always be 0.6 meter. Then the smallest force be F double prime. So we have 150 Newton meter is equal to 0.6. This is R times F double prime sine theta. And we want this force to be minimized. So how do we minimize F double prime? We can maximize something else, right? So because this one is fixed, this one is fixed. So we have this one to minimize it. So this one has to be maximized, and the maximum of sine theta is equal to 1. Let me write it down in complete sentence. Okay. If F is minimized, sine theta is maximized, and IE theta equals to 90 degrees. IE means that is, in Chinese is okay. So if F double prime is minimized, because these two are fixed, and so we need to maximize sine theta. So theta is equal to 90 degrees. So F double prime is equal to 150 divided by 0.6 is equal to 250 Newton. So F double prime is equal to 250 Newton, and going down 30 degrees. Remember that we always have R first. R times F. This is part C. on with any word that I write clearly enough. So we have finished part A to part C. Now come to part D. Part D. Take a time to write this. Horizontal, horizontal means what is this one is so horizontal is this one. Horizontal is this one. And for part D, you need to answer. Let me go to the question: whether the forces obtained from B or C is equivalent to the original force. Equivalent is here. Equivalent is this one. Okay, on page 21, this one. So the forces, magnitudes and lines of action are the same. That these forces are equivalent. So are these forces in A, B, and C equivalent? No, because their magnitudes are different. Okay. For answering these questions, then remember whether if you answer in Chinese or in English, or you see questions in Chinese or in English in other subjects. This one is a yes or no question, right? Yes or no question. In your answer, remember to write either yes or no. You can't, please do not give a very long answer, and I don't know whether you want to answer yes or no. Okay? Answer yes or no first. And so in part D, the answer is no, because the magnitudes of forces are different. Remember, this is on notes, page 21.